Okay, let's move on to the next topic, and we'll talk about mortgage repayment plans. So mortgage repayment plans are simply loan types. So we'll look at 4 loan types that your text describes. And those loan types are interest accruing loans, interest only loans, something called a straight line principal reduction loan, and also a constant payment repayment loan. Now, we'll look at just 4 types of loans, but in reality there are many different types of loans. I mean, in a way, the type of loan is only governed by the creativity of the mortgage broker or of the lender, subject to certain legal requirements, of course. And your text describes a number of kind of modifications of different types of loans, and I'll leave you to look at those in your materials. We'll look at these types of loans because they really illustrate some of the key or main components that go on in mortgage finance. So we'll go through each of these loan types and discuss what makes them unique, and then we'll do an example of each. So that's what we'll do next. So let's look at interest accruing loans first. So what's an interest accruing loan? Well, an interest accruing loan is simply a loan where you borrow the principal, so you borrow the loan amount today, and it's repaid at the end of the loan. So there are no payments made during the loan. So there aren't any payments of interest or principal made during the life of the loan. You simply borrow an amount at the beginning, it's all paid back at the end. That's what it is. Interest accrues or grows or accumulates, whatever term you like, over the life of the loan. All the payments are made at the end of the loan. In terms of risk, we often talk about risk when we talk about loans. Is this loan riskier or less risky than different kinds of loans? Well, what we would say here is that because we're borrowing an amount today, and from the lender's perspective, they're not paid anything during the life of the loan. So they loan an amount today, a year or 2 or 3 years later, they hope to get it all back, but they're not going to receive anything back during the life of the loan. So what we would say is in terms of risk, the principal risk and the interest risk are higher. No principal interest is paid during the life of the loan, so it's a little bit riskier. So you might see this kind of loan in development financing where the developer needs funds to purchase the land, get construction started, but they're not going to see any money back. They're not going to have an ability to make any payments on the loan until later in the construction process, until the units are either sold or the pre-sales are done, or the units are sold at the end of the time horizon. So in that kind of situation, if the borrower doesn't have any ability to pay, they're not going to be able to pay, interest accruing loan might make more sense in that situation. Let's look at an example of an interest accruing loan. So we'll read through the example, then we'll work it out with the equations. This loan simply says, a developer receives a 4-year interest accruing loan of $120,000 at an interest rate of 7% per year. How much will the developer have to repay at the end of the term? Okay. So what we're looking for here is how much you have to pay at the end of the term. Well, the end of the term is the future. We know what the present value is. That's the amount of the loan, $120,000. So we simply need to know what is the future value of that lump sum, $120,000, at the end of the 4-year time frame. Well, this is similar to the question we looked at a little bit earlier. We've got an equation to deal with this. The compound interest formula can handle this for us very easily. And because interest accruing loans don't have any payments during the life of the loan of principal or interest, the compound interest formula works here. So let's use the compound interest formula, and again we'll fill in the blanks. The present value of the loan is $120,000. The interest rate is 7% per year, and we'll write that as a decimal, 0.07. And it's raised to the power of 4 because there are 4 annual compounding periods in this loan. So we'll go through the steps as we did earlier. Deal with the brackets first, then the exponent, then the multiplication. Step will be dealing with the brackets. So 1 plus 0.07 is 1.07. It's still raised to the power of 4, so the exponent is still there. We'll then deal with the exponent, go through that step. Using the y to the x key, it's 1.07, shift y to the x, 4, because there are 4 periods, hit the equal sign, we get 1.310796. Very last step, would be to take our present value and multiply it by that factor. So multiply $120,000 by 1.31, and we'll get a future value of $157,295. So at the end of the 4 years, the developer would have to repay $157,295.52. Now, when we do these calculations, one of the things you can start to think about is your answer that you're anticipating. So in this case, if we borrowed $120,000 today, and we had to pay it back with interest after 1 year or 2 years or 5 years or 7 years, is our future value going to be greater or less than $120,000? Well, it's got to be greater, right? So the direction we can predict. We know that our answer is going to be greater than $120,000. So if you had this question on the exam and you were running out of time or didn't have time to do the calculation, if one of the answers on the exam was less than $120,000, don't choose that, right? So we can often predict the direction. Sometimes we can also predict, well, how big, the magnitude. Well, if we go over 4 years in a loan like this, well, the answer is not going to be $157 million or something that large. So if you've got a number on your calculator that was really large, probably doesn't feel right. So I'm not saying, predict the answers that you're going to get, but if the answer you get is in the right direction, which we can typically anticipate, and it's about the right magnitude, you're probably on the right track, you've probably got the right answer. And that's useful because if you get an answer that doesn't satisfy one of those two criteria, that's a trigger or a hint for you. You might have made a mistake. Go back and check your work. And we'll come back to this nature of direction and magnitude as we go through some of the future examples. Any questions about interest accruing loans? Okay. So let's move on and look at the next type of loan. The next type of loan is an interest-only loan. An interest-only loan is a unique type of loan. In an interest-only loan, the principal amount of the loan is borrowed today, and that's repaid at the end of the loan. So that's not really any different than an interest accruing loan. However, an interest-only loan does have some unique characteristics. Payments are made during the life of the loan, but the payments are interest only. So you can make payments of interest, which is the cost of borrowing, which goes to the lender to compensate them for them loaning you their money. And you can make payments of principal, which go to you to lower the amount of the loan that you've got to repay. Well, no payments of principal are made, just payments of interest. So in terms of risk, we would say an interest-only loan reduces interest risk because you are, as the lender, getting paid interest periodically throughout the life of the loan. But because you're not getting any principal back, the principal risk remains. So sometimes you might get a question about a loan type and about risk, and this is how you manage that. Now, if you think about why would an interest-only loan happen, what's the benefits, what are the advantages? Well, there's a couple of advantages. If we have a regular mortgage loan, our typical constant payment mortgage loan, the kinds of mortgage loans that you and I might have, that loan has two components, or its payment has two components, principal and interest. But if an interest-only loan only has one of those components, the interest, then the payment could be less. So if a regular loan, or regular loan payments rather, are principal and interest, then an interest-only loan payment can be lower. Well, if you're a borrower, is that a benefit to the borrower by making a lower payment? Sure it is. It costs you less. So one benefit immediately is you might be able to make a lower interest-only payment. Now you might say as a borrower, well, if I'm only making one of those payments, not principal, just interest, I'm making a lower interest payment, well, what if you could afford to actually make a greater payment of interest only? What if you could increase your interest-only payment? Well, what does that do for you? Well, you either make a lower payment or you make a higher payment, and you can borrow more. So an interest-only loan allows a borrower potentially to borrow more. And that's a benefit to the borrower. So what it does is it increases the borrower's ability to purchase higher-priced real estate. As we've seen in most markets in Canada, we've seen real estate prices rise very steeply, and incomes rise much more modestly, and we have this gap, this affordability gap they talk about. The difference between our incomes, how much you and I make, and our ability to buy or purchase or afford ever more expensive real estate. So one of the ways to close that gap is through an interest-only loan. So interest-only loan can have that benefit. So this is the advantage of an interest-only loan, and the advantage is, well, what about the other side of the fence? What's the disadvantage of an interest-only loan? Well, if you borrow $100,000 in an interest-only loan today, what do you owe at the end of the year? $100,000, because you haven't paid off any principal. What do you owe 2 years later? $100,000. What do you owe 10 years later? $100,000, right? So interest-only payments never repay the loan. So it's clearly a disadvantage. So that's one of the main components of an interest-only loan. You're just making these payments, never repaying off the loan, so the payments are a little bit like rent. They look a little bit like rent. Now what happens in most of the interest-only loans you see in residential mortgages, there's typically a conversion point. So there's a point at which the loan shifts from being just interest only to being both principal and interest. So you might make interest-only payments for a year or 2 years or 3 years, and then at that point the loan changes or converts to being a loan where you're making principal and interest payments. So then you start to pay off the loan. So really what you're doing is you're simply deferring how long you're going to start repaying the loan. That's what it does. So an interest-only loan, understand what the advantages and disadvantages are. Understand how it is in terms of risk. Reduces interest risk, principal risk remains. And then we'll look at an example and we'll work through and see how one of these examples might work. So we'll do that next. So our interest-only loan example. Again, we'll read through this example, then we'll work through it. This example says, an owner of a development company received a $175,000 loan to buy a small piece of land. The loan is an interest-only loan, an interest rate of 1.3% per month, and a term of 1 year. The question here is, what is the monthly interest-only payment? So we're looking for the payments. Well, in order to calculate a payment, we know that the payment is interest only. And if you recall from some of our earlier discussion, we have an equation that already gives us what the interest would be. And it's this equation. So the interest is equal to the present value multiplied by the interest rate per period, so we have to pay attention to what the period is, multiplied by n. So if we want the monthly interest-only payment, we're just looking for one payment. It'll be the same every month. We're just looking for one payment. So if we're to fill in the blanks here, the present value of the loan is $175,000. The periodic monthly interest rate is 1.3%, or 0.013 as a decimal. And then multiplied by 1. And it's just 1 month because we're just looking for one payment. We're not looking for all the payments or 3 or 4 payments, just one payment. So n is just 1. So that gives us $2,275 per month. So the answer is, what is the monthly interest-only payment? $2,275 per month. And we're done. And that would be the payment you'd make every month for a period of 1 year. So that's a very common question that gets asked on interest-only loans. We didn't have to use our financial keys and our calculator to solve this. We could solve it very simply with an easy equation. I think it's the easiest way to solve this. Sometimes we get asked a slightly different question. So let's ask a different question on the same fact pattern. What if we asked this question? Oops. What if we asked, what is the total amount of all of the monthly payments? Well, we know from our calculation a moment ago, the monthly payments were $2,275. If we want the total amount of all the monthly payments, how many monthly payments will there be? Well, it's a term of 1 year, but because we're making monthly payments, there'll be 12 of them. So $2,275 per month for 12 months. $2,275 times 12, $27,300. So that's all of the payments. So you might get asked a question like that. We could also get asked a different question again. So let's look at a third question based on the same fact pattern. What if it was this question? What amount is paid at the end of the loan? Okay, so let's think about that. Let's think about what happens on this loan. Well, what gets paid at the end? Well, last day of the loan, very last day, you walk into the lender, what do you hand them over? Well, you have to pay them back the present value that you borrowed, so the loan amount is owed, plus the final payment of interest only. So there's two components. So the present value of the loan is $175,000. The final interest only payment is $2,275. At the end of the loan, you repay both those components, so $177,275. So each of those questions illustrates what the unique nature of an interest-only loan. So you could see all of those different kinds of questions asked on an interest-only loan. Let's move on and look at the next type of loan, a loan called a straight-line principal reduction loan. Now, a straight-line principal reduction loan is relatively rare in practice in terms of residential mortgages. So there's nothing for us to calculate here. So we're just going to look at what the loan is, how it works, but there's no numerical example that we'll do here. So if we look at a straight-line principal reduction loan, this is a loan that is repaid with equal principal payments. So the amount of principal you repay stays the same throughout the life of the loan, plus declining interest-only payments. So the amount of interest declines over time. So if we look at a graphic, and this graphic is in your materials, it looks like this. So the horizontal axis is the amortization period. That's the time period over which the loan is repaid. The vertical axis is the periodic payment. And we can see that the principal amount in blue stays the same. So the amount of principal you repay stays exactly the same, but the amount of interest declines over time. The nature of this loan, it's designed this way because of the productivity of the asset being purchased with the loan. The notion being the highest payments are made at the beginning of the loan when the asset is new and it's most productive. So whatever asset you bought, either it's a factory, it's a plant, it's some equipment, whatever you bought, it's most productive at generating revenue for you at the beginning. So you're taking the most amount of money in at the beginning, you've got the greatest ability to pay, so the payments are higher at the beginning, but they decline over time. Now, the reason it's called a straight-line principal reduction loan is if we actually graphed the outstanding balance, and the outstanding balance is the amount that's owing at any particular time during the loan, the outstanding balance, if we were to graph it, is a straight line going down. So it's called a straight-line principal reduction loan because the outstanding balance is a straight line going down. Not a very creative name, but a very descriptive name. So that's what a straight-line principal reduction loan is. So again, nothing for you to calculate here. Just know what it is, know what makes it unique. Principal payments stay the same, declining interest. The notion behind that has to do with the highest payments being made when the asset is new and most productive. That's what you need to know. Okay. Let's now move on and look at the last type of loan, a loan called constant payment mortgage loan. So these are the most common kinds of loans. These are the kinds of loans that you and I have as mortgages. It could be the same for car loans and boat loans and so on. So the way that this loan works is pretty typical. So there's a few things that make a constant mortgage loan unique. First of all of the payments that you make to repay your constant payment mortgage loan, all the periodic payments consist of both principal and interest. So they're always both components. So the payment is equal to principal and interest. When we calculate the payments on a constant payment mortgage loan, the payments that we calculate are determined such that the last payment we make, the end of the loan, will fully amortize or pay off the loan. So amortized or fully amortized just means the amortization period is the time period over which the loan is repaid. So we'll base our payments on the amortization period such that the last payment we make will fully amortize or fully pay off the loan. This also means the future value of every constant payment mortgage loan is zero. So we'll use that piece of information when we calculate a lot of these loans in later sessions. So the future value of the constant payment mortgage loan equals zero. Okay. Let's look at an example of this loan. So I've just made up an example here, nothing for you to calculate here. We'll just look at this for illustrative purposes. So I picked a $100,000 loan, and interest rate J2 equals 5%, amortized over 25 years. I've calculated the monthly payments, and they're $581. And I know they're made up of principal and interest. Now, if I graph or chart these payments, so again, the horizontal axis on the bottom is time. That's our amortization period of 25 years. The vertical axis is the payment. And that orange line you see across the top simply represents the constant payment at $581. So that's the loan. Now, what makes constant payment mortgage loans unique, we know every payment consists of principal and interest, but the amount of principal and interest contained in every single payment changes at every payment date. So I did a calculation. I looked 1 year into the future, so I'm 12 months into the future at the 1 year time frame, and I did a calculation about principal and interest. And we'll do the same calculation a little bit later on. I said, well, how much principal and how much interest exactly are in my 12th payment? Now it turns out that the amount of principal is about $177. The amount of interest is about $404. So it's much higher. So if you've ever had a mortgage loan, you've been paying it off for a few months or a year or two, and it doesn't seem like you're lowering the outstanding balance very much, it doesn't seem like you're paying it off very quickly, well, the answer is you're not, because most of the initial mortgage payment is interest, and of course that just goes to the lender. Principal is what lowers your outstanding balance. And it changes according to this curved line, more or less. It's not quite to scale, but you get the principal. If I did this calculation one more time, this time toward the end of the loan, I said, well, what about if I do the same calculation of principal and interest contained in the payment, but this time it's my 288th payment. So there's 1 year left in the loan. How much principal and interest are now contained in that loan? Well, we can see the amount of principal, $551. Amount of interest, only $30. So it changes dramatically. So if you've ever gotten to the end of a mortgage loan, you'll know that toward the end, you pay the loan off very quickly. And this is why. So this is what makes constant payment mortgage loans